Hi everyone, welcome back to Sri Sampath Vinayaka Learning Easy channel. Today in this video we will discuss about the fundamental theorem on sets. The fundamental theorem of the sets on two sets first we will discuss. That is, let us suppose the two sets A comma B. Then number of A union B is equal to number of A plus number of B minus number of A intersection B is known as the fundamental theorem on sets with two sets A comma B. Okay, and the same thing will be expressed as number of A intersection B is equal to number of A plus number of B minus number of A union B. Just we are doing subject to number of A intersection B. Either of these two are known as the fundamental theorem on sets. Okay, with two sets A comma B. Now let us suppose if A comma B are two disjoint sets. Disjoint sets means there is no common element for the two sets A and B. That means A intersection B is equal to empty. As A intersection B is equal to empty, the number of A intersection B is 0. That means there is no element. That's why number of elements in the A intersection B is going to be 0. If I will write that 0 in the place of number of A intersection B, then that number of A union B is going to be number of A plus number of B. This is a very important formula. So number of A union B is equal to number of A plus number of B. Okay, now we will discuss the fundamental theorem of sets on three sets. Like A, B, C are the three sets. Then the fundamental theorem on sets for the three sets A, B, C is number of A union B union C is equal to number of A plus number of B plus number of C minus number of A intersection B minus number of B intersection C minus number of C intersection A plus number of A intersection B intersection C. Okay. If you want to write the same fundamental theorem on sets for three sets X, Y, Z, then number of X union Y union Z is equal to number of X plus number of Y plus number of Z minus number of X intersection Y minus number of Y intersection Z minus number of Z intersection X plus number of X intersection Y intersection Z. Okay, in this way we will write the fundamental theorem on sets for the three given sets. Okay, I hope you understand this. Now we will discuss one or two examples on the fundamental theorem of sets. Example 1. If number of A is equal to 25, number of B is equal to 15, number of A union B is equal to 30, then he is asking us to find number of A intersection B. Okay, we know that number of A intersection B is equal to number of A plus number of B minus number of A union B. Just we have to write the given values here. Number of A 25, number of B 15, minus number of A union B is equal to 30. That is equal to, it is 40 minus 30. That is equal to 10. That means number of A intersection B is 10. Now another example C. Number of A is equal to 10, number of B is equal to 15, number of C is equal to 20, number of A intersection B is equal to 4, number of A intersection C is equal to 7, number of B intersection C is equal to 10, and number of A intersection B intersection C is equal to 3. Then he is asking us to find number of A union B union C. We know the formula for number of A union B union C as number of A plus number of B plus number of C minus number of A intersection B minus number of B intersection C minus number of C intersection A plus number of A intersection B intersection C. We will substitute their given respected values here. Number of A means 10, number of B means 15, number of C means 20 minus number of A intersection B is 4, number of B intersection C is 10, number of A intersection C is 7 plus number of A intersection B intersection C is how much? 3. See here this negative 10 and positive 10 will cancel out. Okay, now coming to this 15 and 20, 35 plus this 3 is 38 minus 4 minus 7 is minus 11. That is going to be what? 27. So number of A union B union C is equal to 27. I hope you understand this. Thank you for watching this video. If you like the video, please share the video with your friends. Thank you.